some of the other things you just want to know to be able to eliminate questions and things like that. Now, I'll be asking you individual questions as we go along. So make sure you pay close attention. Okay, everybody got it? So let me go ahead and present bar. Perfect. Okay, so basically, when you're looking at the endocrine system, the endocrine system basically starts right up here at the head in the brain, right, and it goes all the way down to the toes. Does it go to the toes? Anybody agree? Disagree? Does it go to the toes? Have you learned how to use your agree and disagree? No, it does not go to the toes. Don't let me just tell you anything. You all about to be doctors. So no, your endocrine doesn't go to your toes. You don't have any actually endocrine glands in your toes, I don't think. That we've noticed or we found out yet. So the way we're going to look at this is we're going to start in sort of what we call a hierarchy fashion. We're going to start in the brain, and we're going to look at how the brain controls other areas all the way down to what we call the primary organs, okay? So in the brain, you have this thing called the hypothalamus, right? The hypothalamus. Now, the hypothalamus is actually part of what we call the forebrain. So you probably learned this in the nervous system. But if you, just in case you didn't, the brain is divided up into three sections, right? The forebrain, the midbrain, and the hindbrain. And in the forebrain, you have what we call the telencephalon and the diencephalon. And one easy way I like to remember this is tel die, mes met my. So tel die, mes met my. Sounds like a little story. So we tell, who do we tell? Now, you know I ask questions. So if you want to be here all night long, don't answer. If you want to get through this quickly, somebody needs to answer quickly. So tell die, mes met my. So tell who? Tell die, good. What do we tell die? We tell die that who? Mess. Who did mess? Mess did what? Met, and it met mine. Perfect. So tell die, mess met mine. So that's wonderful. Now you're probably asking, what in the world are you talking about, Dr. Sutton? Well, tell die is the telencephalon and the diencephalon. So you break it up 2, 1, 2. Tell die, mess, met my. Tell die, mess, met my. So the forebrain is the telencephalon and the diencephalon. The midbrain is the, what's the midbrain? Thank you, John. Thank you. And then finally, the hindbrain is the good and there's two things, right? Good. Met and my. Okay. Now, you probably said, why in the world did I tell you that considering we just went over the nervous system? Well, the diencephalon has two components of the diencephalon. Does anybody know the two structures that are in the diencephalon? It'll be faster if you see on your little thing. You can put agree, disagree, right there where the guy is raising his hands. So if you don't know, just throw a little disagree sign or something. And if you do know, thank you, John. All right. So the diencephalon is made up of the thalamus and the hypothalamus. The hypothalamus, the function of the hypothalamus is basically to control things that are related to hormones. One way to remember it is that things that are hormonal. So sex is hormonal. Temperature is hormonal. What else? thirst, right? And things like that. So you want to remember that. The other way that medical students remember the hypothalamus, they say anything that happens after sex. And so they say, well, after sex, you get hungry, you get sleepy, you get thirsty, and your hormones are raging. So those are one way that's another way to remember hypothalamus. Everybody got it? Thank you, John. Thank you. Okay, good. Now you're getting it. Now you know this is very interactive. You know I'm going to ask you questions because at the end, I'm going to ask you questions to make sure. So the hypothalamic hormones, those hypothalamic hormones, the easiest way to remember it is that anytime that you see a hormone with the word releasing in it, you know it comes from the hypothalamus. Everybody get that? If it has the word releasing, so if I say corticotropic releasing, if I say thyrotropic releasing, gonadotropic releasing, if I say the word releasing, where does it come from? Thank you, John. From the hypothalamus. Perfect. So, since it's releasing from the hypothalamus, it's acting somewhere else, right? So, if you look here, the hypothalamus is here. Right under the hypothalamus, you see the pineal gland. In the pineal gland, I want you to write for the pineal gland that it has one hormone that you want to think about. Oh, let me see that. Uh-oh. So in the pineal gland, the hormone that you want to remember is a hormone called anybody know? Melatonin. Very good. Melatonin actually comes from an amino acid called tryptophan. Tryptophan is what we find in turkeys, right? What happens after you eat a big meal after Thanksgiving? You get sleepy, right? You get sleepy. So melatonin is one of those things, those hormones, that actually regulates your sleep-wake cycle, okay? So that's what you want to know about the pineal gland. That's what's in that thing. Then we get to the pituitary gland, okay? And so we'll look at all these glands just in a few seconds, but let's go through some. First thing you want to know is, why are hormones even needed? Why do you need these hormones, right? Well, they're chemical messages from one part of the body to the other. That means that the message, those things that I need to happen, say, in my arms or in my stomach or in my chest, those things are communicated via a chemical release in the brain. And so we know chemical release means hypothalamus, right? If you see the word stimulating, you should be thinking about a pituitary or a part of the pituitary, okay? So here, anyway, let's keep going. So here you see they communicate to the whole body. They're not going to ask you that on the MCAT. Then they talk about they regulate homeostasis and large-scale changes. True. So homeostasis is just the balance in your body, making sure everything is all balanced. Well, that's one of the major things for temperature control. And where's temperature control regulated from? Oh, very good, John. The hypothalamus. Good. Good. So everybody got the hypothalamus. Perfect. So, all right. So those are some of the things we talk about. Well, they regulate solutes and levels in the blood, and we'll look at some of those. Glucose, calcium, and salts, metabolism. Metabolism is mainly thyroid. So that'll be your thyroid hormone. But we'll see the growth hormone, development. So anyway, they do all that stuff, which we don't look at this deeper dive. Now, animals rely on two systems. Well, the first one is the endocrine system, and the second one is the nervous system. You've already learned about the nervous system. Now it's about the endocrine system. Well, the endocrine system, basically, now here's a good question. The difference between the endocrine system and, say, the exocrine system. The endocrine system basically sends things via ducts or most things that are transported through blood is via the endocrine system. Typically, when you have ducts, things like that, they are the exocrine system. Does everybody understand that? Yes? All right. Okay, good. Okay. So the next thing that we're going to be saying is that they secrete chemical signals through the blood, they target tissues, and they target cell receptor proteins sometimes, and then they're slow, long-lasting response. Now, let's look at this. When you talk about tissues, now tissues, when we say tissue, is that in the blood or not in the blood? Not in the blood. Perfect. So that means that what happens is that these hormones are circulating via the blood, and then they are trying to reach certain tissues so that they can have function. Because what makes up a tissue? Cell. And so most of what you need occurs at the cellular level. So you need those hormones to go through the blood, hit the cells, and cause some type of change or some type of action to happen in the cell. Everybody with me? I'm assuming that. All right. Let's go. Okay. So we learned about that. Okay. So basically, the regulation of these chemical messages. So here, you should have learned in the nervous system about this thing called an axon, right? And in the axon is basically comes from a cell body, and this action potential is propagated down that axon, right? Now, what provides myelin, say, in the brain? Let's see, Momin. What provides myelin in the brain? I don't know. John? I don't know. Wait a minute. Now, I know good and well you all just had the nervous system. Raise your hand if you know what provides myelin to the brain, in the brain. Yeah, but what provides it? What's the cells that provide myelin to the central nervous system? Okay, not myelin sheath, no. Schwann says no. Close, John. Actually, myelin in the brain comes from what we call oligodendrocytes. Have y'all heard of that? Oligodendrocytes, right? And then if you have myelin in the periphery, then that is done by Schwann cells. Now you all need to remember these things because these things are on the MCAT, and those would be a discrete question. That would not be a passage-based question. That would be something that you need to understand. So make sure you all are reading your books, okay? It's important that you read. Don't just come to class. You have to read everything that's in those books, page to page, and really know it, okay? So anyway, what happens though is that once that chemical is released into a synaptic cleft, it can bind on the postsynaptic side and cause some different things to happen. Well, one of the things that can happen is it can signal the release of different hormones. So, one of the things that they talk about is a neurotransmitter released by the neuron, because that neurotransmitter is going to signal like the glands or the particular gland to release that hormone. Now, what is the most common neurotransmitter? Raise your hand if you know. Joan doesn't know. Okay. Thank you. All right. Go ahead, John. What is it, John? Yeah, that's right. So, right, he's right. The most common neurotransmitter is acetylcholine. Acetylcholine you're gonna find everywhere. You're gonna find it in presynaptic ganglion, presynaptic. Well, I mean, you're gonna find it in preganglionic uh, neurons, and you're gonna find it in the postganglionic of the parasympathetic, and some sympathetic, but mostly sympathetic is norepinephrine. Anyway, we'll keep going. So that's your neurotransmitter. You see your receptor proteins, right? And then from there, the endocrine gland and the hormones carried by the blood, like I told you. And then you have your receptor proteins, okay? And lock and key system. Yeah. Lock and key or induced fit. Now, they may ask you a question about that. Lock and key is like old school, but they still kind of apply it in some cases. Induced fit also. All right. So here are the different classes of the hormones. You got your proteins and your lipids. Easy to remember. Which one do you think is hydrophilic? Protein. Good. Very good. So, which one do you think has its receptor on the cell membrane? Okay, John says proteins. Everybody agree? Well, let's take a look. She is absolutely correct. So basically, if it's hydrophilic, that means that it cannot cross that phospholipid bilayer without some assistance, right? And so proteins basically are what we call hydrophilic. These are polypeptides that, such as insulin, ADH, antidiuretic, and glycoproteins, things like that. Large protein. Okay, so anyway, anytime that you see a protein-based hormone, you already know that its receptors are located on the cell membrane. Do you all understand that? Good. Now, since you understand that, do you think a protein-based hormone will undergo a second messenger system? Yes, the answer is yes. Because you think about it. Basically, once that protein-based hormone binds to its membrane receptor, it's going to signal a cascade to occur inside the cell. So that's almost like somebody knocking on your front door who you don't recognize. Well, you recognize them, but you just don't let everybody in your house. And so when you see them, they look familiar, but you turn to your brother or your sister and say, hey, do you know this person? They say, yeah, I know this person. And then they say, oh, okay, fine. They don't let them in, but what they allow to happen is that the changes that they can influence happens inside the cell. So basically, anytime that it's a protein-based hormone, know that a second messenger is involved. They like those questions on the exam. Now, you may be saying, well, how do they ask the question about that? Well, easy. They can just give you a hormone, or different types of hormones, and then they can tell you that one is lipid-based, and then they can say, okay, this hormone is a steroid hormone, and that's all they tell you. Then they say, which of the following all the following are true regarding steroid hormones except, and then they'll give you something like has a cellular membrane receptor, stuff like that. So y'all understand. Okay. All right. Epinephrine, melatonin. Where do you find melatonin, Ambria? That is absolutely correct. So lipid-based hormones are our steroid hormones. Now, how do you identify a steroid hormone on the exam? What does it end with? What three letters? Thank you, Ambria. Perfect. ONE. Testosterone, progesterone, aldosterone, any of those ONEs. But also, one of the steroid hormones that may not sound like a steroid hormone, but it is a steroid hormone. It ends in OL, and it's called cortisol. And we'll look at cortisol when we look at the adrenal gland. Okay, everybody got it? Perfect. Let's go to the next thing. Now, you all do know that steroids do come from cholesterol, right? That is the precursor. How do hormones target cells? Well, let's look at it. Now, we said that lipid-based hormones are hydrophobic. They diffuse across the cell membrane because you remember like dissolves like. So their membrane, their receptor proteins are in the cytoplasm and the nucleus of the cell, not on the cell membrane. All right? We're going to keep moving. Then you get to these protein-based, which are hydrophilic.
What?
They cannot diffuse across the cell membrane. So they must bind to their receptors on the cell membrane and undergo a second messenger pathway, right? Now, lipid hormones bind to what we call transcription factors, right? Now, what is transcription, Danish? Okay, so Danish doesn't know. How about Moment? What is transcription? Is this
going from DNA to mRNA.
perfect? Very good. Great job. Okay. Good job, Moment. That's exactly what transcription is. So what lipid hormones do, they can actually bind to these transcription factors. So they literally can affect the gene, which is major. So y'all know how steroids work, right? So good thing. All right. So we're gonna keep moving. Now here you're gonna see the action of a lipid or a steroid hormone. Okay. And so just by a show of hands, or not hands, but checks, who would like this PowerPoint? Anybody like it? Anybody want it? Anybody want it? Okay. Okay, Ambria. Well, I will send. Okay, good. All right. Perfect. So, action of steroids. So if you look at this is cool stuff, right? So you got the blood. You see the blood over there, right? And then you see the steroid hormone. Well, guess what that steroid hormone is going to do? That steroid hormone is going to find this target cell. That target cell is going to be inside or outside. The target cell, okay. Plasma membrane. Cytoplasm. So you want to tell me what a target cell is again? For the steroid hormone? Is a steroid hormone a lipid or a peptide? It's a lipid. So if it's a lipid, where would you find its target? Yeah, it could be in the nucleus or it could be in the what? It can definitely be in the nucleus, but it also can be in the cytoplasm. In the cytoplasm. All right, doctors. Come on, doctors. We need you to step up. Come on. I got this, okay? I already told you that. I told you if it's a steroid hormone, that hormone is going to be the steroid receptor. So that receptor cell or the target cell for that steroid is going to be located inside either in the cytoplasm or the nucleus, okay? All right. We're going to keep moving. You cross the cell membrane. Once you cross the cell membrane, you see the receptor. It binds to the receptor. Once it binds to the receptor, you can actually affect the DNA. Once you do that, you basically become a transcription factor, which alters DNA to mRNA replication or DNA being converted to mRNA. And finally, that mRNA that's going to be exiting the nucleus may not look like the mRNA that you had before. Do you think that's a problem? Yes, sure. And so, you ever heard about people on steroids whose hair starts falling out because they're on steroids or they develop real bad acne? Yeah. And so what that is that, your hair is actually the result of proteins, right? So when you undergo translation and protein synthesis, The reason that you have hair is because of a protein. And what happens is it curls a certain way or it straightens a certain way to determine that you have hair. Just like when my hair goes from black to gray. Now you see my hair is like gray and black. Now you know why it's gray, right? Everybody know why it's gray? Jones says you don't know. Does anybody know why my hair is gray? I just gave you a clue. Roman says no. Anybody? Uh-huh. Okay. Guys, and I want you to hear me very, very closely. I have been on the admissions for 5, 6 years. I've seen a lot of students take the MCAT. I have interviewed a lot of students in medical school. I got to tell you that you have to participate. Even if you don't know, you got to be involved. You got to throw stuff out there. You got to challenge yourself. You got to take this MCAT super serious because you going to medical school is in your hands. Does everybody understand that? If you put in the work, you will go to medical school. But if you slack, you know that slacking will not get you there. Everybody follow me? All right. Okay. Well, anyway. All right. Yeah, I guess. So, basically, yeah. Hello. Hello. Dennis, do you have a question? Okay. So anyway, that's basically how the lipid works. Okay. The reason I have gray hair is because students don't study before they come to my class. That's why I got gray hair. All right. So we're gonna keep moving, and we keep moving, and we keep moving, and we keep moving. So basically, this steroid that you initially have goes into the cell, can go into the nucleus, become a transcription factor, alter your mRNA, and the mRNA is going to create some other protein, and that protein is going to be secreted. Okay? The take-home message that you should remember about this is that if you have a steroid hormone, that steroid hormone can alter the protein that you would normally produce. If it does that, it can lead to sterility in men, what we call acne, growth problems, bone density issues, hair loss, all those kind of things. Anything that you think of a protein affecting, that's what it can do. All right, now, the action of protein hormones, okay? Now, protein hormones are peptide hormones. Everybody understand that, right? Because proteins come from amino acids, and amino acids are linked together through a peptide bond, and that's how you get protein hormones. Okay? Now, the protein hormones, where's their target? Where's their target? On the cell membrane. Perfect. Does it undergo a second messenger? Thank you. Good. Perfect. So let's see what happens. Okay, so we're gonna take a little look. It hits the target, and let's take a look. So number one, you get the signal. All right, binds to the receptor protein. Number two, it activates the cytoplasmic signal that we call a second messenger. That second messenger could be GTP. So that GTP is an energy source, right? GTP. Anytime that you see GTP, ATP, AMP, ADP, what is the enzyme that you think is associated with that? Thank you, John. Very good. A kinase. Definitely it's a kinase. Perfect. So anyway, you activate that. It activates a G protein, which activates an enzyme. I wonder which enzyme. Then it activates ATP. The ATP goes into this thing called cyclic AMP. Now, when you actually get to medical school, it's going to be a lot more detail. But I will just say this. Cyclic AMP is a second messenger only for a few hormones. So certain second messengers recognize certain hormones. The cyclic AMP can recognize things like thyroid hormones. Okay. Acts as a second messenger, activates an enzyme, so it's all about the enzymes, transduction, second messenger system, produces action. Now, you probably wondered how can they ask you a question. Well, guess what? They can give you some theoretical passage, some hypothetical passage about some hormone X that binds to the cell membrane. Then they're going to say that it's going through this long cascade of things, where it's going to activate this protein kinase A, blah blah blah. All that is not what you're looking for. Passages like that, the answers are in the passage. What you need to know is just the basics, and then be able to extrapolate from the passage the information you need. So, for instance, what you need to know about this is that a protein will bind to a membrane-bound receptor. That peptide will bind to that membrane-bound receptor and activate a second messenger. It can undergo different types of second messengers, but if you see one that involves ATP, then you should be thinking that that enzyme that's going to be related to it is a kinase. Okay? And that's it. Signature transduction. Now, action of epinephrine, norepinephrine. Now, I'm sure you all learned about. Well, I know you learned about it because I saw Visha's notes, so I know you know this already. But epinephrine and norepinephrine, where epinephrine comes from the phenylalanine pathway of amino acids. So phenylalanine is an essential amino acid. Okay, it's an essential amino acid. And meaning, when we say essential amino acid, that means it's an amino acid that you have to take in the diet. Phenylalanine gives rise to an amino acid called tyrosine. Tyrosine gives rise to an amino acid called dopa. Dopa gives rise to dopamine. Dopamine gives rise to norepinephrine. And norepinephrine gives rise to I can lead you to water, but I can't make you drink. I cannot believe y'all don't know this answer. I led you the whole way. I just told you. Come on, guys. Look at what I'm saying. Thank you, Moment. Yes, epinephrine. I just said all the way. Phenylalanine to tyrosine. Tyrosine to dopa. Dopa to dopamine. Dopamine to norepinephrine. Norepinephrine to, and it seems logical, the next thing would be epinephrine. So anyway, epinephrine is adrenaline, and that's that thing. So most times adrenaline or epinephrine is secreted at the post-ganglionic or the pre-ganglionic. Y'all heard me today. What are y'all doing? Okay, don't worry, Joan. I'm just, thank you, Moment. But now, Joan, what I appreciate you doing, Joan, you at least trying. You at least answering questions. That means a lot. But so in your preganglionics, all the neurotransmitter at all preganglionics on the sympathetic or the parasympathetic is the acetylcholine. Okay? At the postganglionic of the sympathetics is where you would find like norepinephrine, epinephrine. Everybody got that? Yep. So anyway, epinephrine is a vasoconstrictor. But here's how epinephrine works. Okay? So epinephrine, first of all, we're gonna take a liver cell. Now, what's the other word for a liver cell? What's the other word for a liver cell? Does anybody know what the other word for a liver cell is? Hepatocyte. Very good. So anytime you see the word hepato, then you know that's a liver cell. Outstanding. Constance, you missed the first part. Can you hear me, Constance? You can type it if you can. Say yes or no. Anyway, we'll keep moving. Okay, so here's the cytoplasm, receptor protein. Then you got this nice adrenal gland. Isn't this a beautiful adrenal gland? What is this thing right here? Where my pointer is. Can y'all see my pointer? Oh, y'all can't see my pointer? Oh, y'all don't see my cursor? Hold on, let me get my pointer. Hold up. I can make it work. Can you see the little green thing that I just put on there? Okay, what is this thing that I'm pointing at with the green thing? Kidney, perfect. What's another word we use for kidney? Renal, perfect. And what is this thing right here above the kidney? The adrenal gland, outstanding. So now you all are back on. Now you get it. I know I just had to wake you up. I know y'all did. Okay, so epinephrine will bind to that membrane-bound receptor. It will activate a second messenger. That second messenger, GDP, activates a G protein. Does this look familiar like we've seen it before? Sure you have. We saw the same thing when we looked at what? Peptide hormones. So it's going to activate this thing called adenylyl cyclase. And then what it's going to do, cyclic AMP, seen that. Protein kinase A. You know ATP is involved. And then you go from there, activates the phosphorylase kinase. And then phosphorylase. Now, does anybody know what a phosphorylase does? Yeah, phosphorylase. So, see this thing right here I'm pointing at? Phosphorylase? Does anybody know what phosphorylase does? No, okay, so Moment says breaks inorganic phosphate off of. Okay, so Moment, you close. So phosphorylase will actually add a inorganic phosphate. A phosphatase will actually take away an inorganic phosphate. So that means that it's a phosphate that's not attached to ATP. Does that make sense? Because if it's attached to ATP, we already know that the enzyme is a kinase, right? And a kinase can either take away a phosphate or add a phosphate. But a phosphorylase will add a phosphate add an inorganic phosphate. Everybody get that? Okay. Glycogen. Now, let's see. Glycogen. Can you repeat that? I don't even know what I said. I forgot the last thing I said. So phosphorylase. Oh, Moment has a question. Go ahead, Moment. Moment. Oh, okay. Well, turn your mic off, Moment. Thank you. All right. So here we have Moment. Thank you. Okay. Okay. Thank you. All right. So phosphorylase, basically, when you see glycogen phosphorylase, what that's going to do, it's going to produce Okay. So glycogen. What is glycogen? Oh, thank you, Jones, for helping. You answered my question for me. That's good. Thank you, Jones. Very nice. So glycogen is what kind of sugar? It's a storage form of sugar, right? Where's glycogen stored? Very good, John, in the liver. Exactly. And so you store that glycogen in the liver until you need it. Okay? We keep moving. There's release to the blood. Blah, blah, blah. All right, so the benefits of a second messenger. Well, I don't know. Well, we know what the second messenger is, but what is the benefit of a second messenger? Uh-oh. Amplification, 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 amplification. So what is the benefit of a second messenger system? That is correct. Amplification. Yeah, I got it. Good, good. All right. So everybody's understanding this, I'm assuming, right? So in a second messenger system, you're going to get a very fast response, right? So you know this already. If you took like hormone pills, you took a pill, um, if it has to go inside the nucleus and do some stuff in the nucleus, as opposed to if it binds, it amplifies real quick, then that's going to have a faster response. Maintaining homeostasis, I don't care about that right now. We'll talk about this in a minute. We'll go past that. Body temperature. We'll go through all that. Okay. Now, what type of hormones? See, all of this right here is just maintaining homeostasis, okay? So, for instance, if your blood sugar is low, then your body wants to do what? If your blood sugar is low. Okay, right. So if your blood sugar is low, you want to raise blood sugar. So glucagon is what raises blood sugar. So you want more glucagon. If your blood sugar is high, then you don't want more blood glucose. Then you want less, so then you need insulin to be released. Okay, I hope everybody's good. We're going to keep moving, We're going to get to the fun stuff. I know what you're waiting on. Now, here, if you look at this, this talks about blood osmolarity, right? Now, what is osmolarity? Yes, Constance, I will send you the slides. What is blood osmolarity? Water diffusion. Okay, good. So we know that water diffuses from a blank concentration to a blank concentration. From high to low. Okay? From high to low. So water will diffuse. Okay, so are you talking about high to low water concentration or high to low solute concentration? Solute? Okay, so if water is going to diffuse, it's going to go from a low. Okay, you're right, John, if you said water. But so really, osmosis is the movement of water from a low solute concentration to a high solute concentration. Or, like John says, it's basically the movement of water from a high water concentration to a lower water concentration. Perfect. So know both ways to remember that, okay? Now here, this thing called ADH is antidiuretic hormone, and we're going to see that when we look at the posterior pituitary. And renin-angiotensin system is a wonderful, wonderful system that you want to know about. And all this is just regulation. All right. Now, hypothalamic hormones. Now, when we say hypothalamus, what's the hormone name that we're thinking about? What's in the word? Releasing. Exactly. So the nervous system releasing. Good. So receives information from nerves around the body. Releasing hormones. Look at that. Regulate the release of hormones from the pituitary. The pituitary is your master gland. You got an anterior pituitary and you have a posterior pituitary. The mnemonic, the way to remember anterior pituitary is, anybody know the mnemonic for all the hormones that are in the anterior pituitary? Nope. The mnemonic for all your anterior pituitary hormones are, did y'all see what I just put down there. That is for the anterior pituitary. Everybody got that? Now, what does the F stand for? Good. Follicle stimulating hormone. Perfect. What is the L? Hello. Uh-huh. All right. Now, I did mention that these are the anterior pituitary hormones, right? Did you all read the endocrine system before you came to class today? Okay. All right. Guys, listen. You already know what's on the agenda. You already know what you have to read. So before you come to class, read the chapter. Read whatever we're going to be covering in class so you'll understand it better. Does everybody understand that? So we won't have this issue again. Never, ever again will we have this issue. Okay? All right, so L is luteinizing hormone. A is adrenocorticotropic hormone. Okay? What else? The T is thyroid stimulating hormone. The P is prolactin. The I, we're just going to say inhibin, but it has some other things that we'll call it, but that just makes the P work. And the G is, okay, everybody understand that? That is flat pig, okay? Those are the hormones of the anterior pituitary. The anterior pituitary is what we call the adenohypophysis. Adenohypophysis. Okay? The adenohypophysis is we're going to say under vascular control. The reason I'm telling you this is because this was something that was on the MCAT. So the adenohypophysis is under vascular control, where the neurohypophysis is under neural control. Everybody with me so far? You understand that? I hope so. All right. Okay, good. All right, so let's keep moving. So basically, if you look at the hypothalamus and the few hormones that they have there, they give rise to all the other hormones that can be released. So, for instance, in the hypothalamus, you have, let's look at some of these, what we call tropic hormones. And I'll just go ahead and put these up here. Okay. So here, these are called tropic hormones. That means that they actually target the glands themselves, they target the endocrine glands, okay? You have the anterior pituitary, which I just told you was called the adenohypophysis. And you have the posterior pituitary, which is the neurohypophysis. These are the only two hormones in the posterior pituitary, which are oxytocin and ADH. Does anybody know the other name for ADH? I mean, if you read, you probably would, but if you didn't read, you probably won't. Nope. Okay. All right. ADH is vasopressor. Okay? ADH is vasopressor. Tell you what we're going to do. Because I'm not happy right now. I'm very upset. Because these are things that we should be having a conversation about. And people should be answering these questions. So this is not good. Thyroid stimulating hormone, TSH, is in the anterior pituitary. All of these right here are your flat periods. You see the FSH, you see the LH, you see the ACTH, you see the TSH, you see the prolactin. This melanocyte stimulating hormone, this is where we actually put the word inhibin, but that word inhibin and then growth hormone. So this is your flat period. So everything in a blue-like color, blue light, is your anterior pituitary. Everything in this kind of purple and off lavender or whatever color, that is your posterior pituitary. Easy to remember. There's only two in the posterior, and these are the ones in the anterior. Everything that's coming from these glands are going to be targeting something else. So the thyroid TSH is going to be targeting the thyroid gland. The ACTH is going to be targeting the adrenal gland, particularly the cortex, not the medulla. In the medulla of the adrenal gland, you have the norepinephrine, epinephrine, the catecholamine, the bones and muscle growth hormone, and everything like that. Now, the other point that I want to make here is that everything here has some type of connection to the hypothalamus. So remember that, what I just said. Everything here has a connection to the hypothalamus. These two hormones in the posterior pituitary are actually produced in the hypothalamus, but stored in the posterior pituitary. These are not produced in the hypothalamus, but they have a function where the hypothalamus releases something in axon. Okay. Prolactin. Well, of course, prolactin is for milk. So pro means promote. Lactin means lactation or lactose. So when you don't know what the word prolactin means, it just means milk production. It doesn't mean the actual milk that's being ejected. Milk coming out of the breast is due to oxytocin. Prolactin is only responsible for milk production in mammals. Everybody understand that? Okay, all right. So let's look at what's going on here. Now, you remember I told you everything in the anterior pituitary has a effect on the, on everything on the hypothalamus has an effect on the anterior pituitary. Well, look here. If you see TRH, where is that going to be found? Thank you. Hypothalamus. That's right. And so TRH obviously is going to affect TSH. And TSH is found in the anterior pituitary. So you can see how this works, right? TRH acts on the anterior pituitary to cause the release of TSH. TSH then goes and acts on the thyroid. Thyroid goes and then produces thyroxine. Thyroxines are your what we call T3 and T4. Okay? So T3 and T4. These are your thyroid hormones. Okay? T3 is metabolically active. T4 is not active. T4 can be converted to T3 through iodine. Everybody understand that? I hope so. Good. So if you have a lot of T3, we call that hyper means a lot, thyroidism. Hyperthyroidism can lead to things like goiters, exophthalmos, which is the bulging of the eyes, decreased weight, because the thyroid gland regulates your metabolism. So if you have a high metabolism, you do not gain weight. That means that you're sensitive to heat, stuff like that. So you see about how thyroid can be converted to thyroxine plus iodine. Okay? Now, let me ask this question. Why is it that certain, let's say, certain certain cultures or countries have higher incidences of prevalence of goiters. Lack of iodine, right? And one of the things that they can put on the test is that they can be telling you something about sea salt. Does sea salt have iodine in it? Yeah. Oh, perfect. So here is what we looked at. So this is what we're talking about with the goiters. And so let me go back. Everybody saw. So basically, if you have like regular salt, it's called iodized salt. And then iodized salt is basically, has iodine in it. This is what we call a goiter. This is actually a goiter. Everybody understand that? Uh, go ahead, Donish. Go ahead, Donish. Oh. No, so sea salt doesn't have that. No, sea salt doesn't have it. So since sea salt doesn't have it, people who have diets that are strictly sea salt are going to be more likely to develop a goiter than someone else who did. Okay, but there are other ways you can get iodine in the diet. And to answer your question, Constance, basically what it does is it converts those thyroid hormones to thyroxine, so the T3s and the T4s. Okay. All right. So now we're going to look at how you regulate blood calcium. Okay. And one of the things that the thyroid gland does, so we already know that the thyroid gland produces T3 and T4. The other thing that it does is it produces something called calcitonin. Does calcitonin increase or decrease blood calcium? Yeah. Now, so calcitonin, so think of it like this. Calcitonin tones the calcium down in the blood. So when we say tone the calcium down, like tone it down, like if the music is too loud, we say tone it down. So calcitonin actually decreases blood calcium. Okay? That's the opposite of what we call parathyroid hormone, which increases blood calcium. So calcitonin decreases blood calcium. Parathyroid hormone increases blood calcium. Blood calcium. Everybody got that, right? Now, we'll keep going. So basically, if you decrease the blood calcium, that means calcium got to go somewhere, right? So where's calcium going to go? Bones, exactly. In the cells, bones, good. So basically, calcitonin, will it make strong bones or weak bones? Very good. All right. So then if you have low blood calcium, right? Say your blood calcium is low, then you release something called parathyroid hormone. Parathyroid hormone is going to increase blood calcium. But if you're increasing blood calcium, where are you taking blood from? Where are you taking calcium from? Bones. Exactly. So the bones become what? All right. Now, parathyroid gland is responsible for parathyroid hormone. All right. Perfect. All right. Pregnancy. Okay, the female reproductive cycle. Now, in the hypothalamus, we said the thyrotropic releasing hormone. Now, here, in the female reproductive system, you should know that the hypothalamus has something called gonatotropic, gonatotropic releasing hormone. So what do you think this does? What do you think gonatotropic releasing hormones do? Release hormones from the ovaries. Okay. So gonadotropic hormones, yeah, you kind of right, Joan. That's not bad. Release hormones from the hypothalamus. Okay. Release estrogen. Okay, so y'all are all on the right track. They're all related to the reproductive system. So the gonadotropic releasing hormone, always remember this though, guys. And I don't want y'all to forget this. If it's a hormone that's in the hypothalamus, where is it acting? Where's it going to act on? Thank you. Very good, Constance. On the anterior pituitary. And so if you know it's going to act on the anterior pituitary, then you should already know what hormones are in the anterior pituitary that deal with reproduction. What are they? Luteinizing hormone and follicle stimulating hormone. Very good. Absolutely. Good job. Okay? So that means that the gonadotropic releasing hormone will act on the anterior pituitary hormone. And you got, now y'all see GnRH, right? Perfect. And you see then you see the pituitary gland, FSH and LH. Then the FSH and LH is then going to work on those things that you were talking about, like the ovaries. And there's the estrogen. And then there's the eggs. Builds up in the uterus. You form the corpus luteum, which you'll learn about in the reproductive cycle. Then you get progesterone. Maintains that lining and all that other good stuff. So these things you will actually learn in the reproductive cycle when I go through the repro. Key thing here is know what GnRH does, what FSH and LH. Yep, all that other good stuff. All that good stuff. All right. Nope, no question. Look at that guy. 8'11". He lived from 1918 to 1940. What do you think his problem was? Growth hormone. What is that condition called? Gigantism. Exactly. If he had developed this as an adult, what do we call that? It's not called gigantism if it's an adult. What do you call it if it happened when he was an adult? It's called acromegaly. Megaly something. That's good, guys. That's good. It's acromegaly. So that is him. 8'11". That is super, super tall. How did he get the clothes? Anyway, stresses of the body. So basically, when a body is stressed, the body's going to respond to stress. The major stress response is something we call cortisol. Cortisol is located in the adrenal cortex. The adrenal cortex, right? Everybody understand that? The adrenal cortex is broken up into 3 zones. The zona glomerulosa, the zona fasciculata, and the zona reticularis. Those are the 3 zones that you will find these things in the adrenal cortex. The zona glomerulosa deals with salt. So anything that's related to salt or salt reabsorption is in the zona glomerulosa. The hormone that you find in the zona glomerulosa is one that we call aldosterone. Al is a bitter man. He's a very bitter man, so we know he's involved in salt. He is so bitter that he causes salt to be reabsorbed into the blood. When that salt goes into the blood, that causes water to follow. When water follows, that increases the pressure. That means Al is bitter and he has high blood pressure. So aldosterone. That's all I'm going to say with that. Zona fasciculata. That's the second zone. Second zona fasciculata is the one that's involved with sugar. It's something sweet. What we talk about with fasciculata is what we call it a glucocorticoid. glucocorticoid. And when you see that, you should also be thinking about cortisol. Cortisol is your stress hormone. So whenever you're getting ready to take a test and the hormone is released, it's cortisol. That's the zona fasciculata. The last zone is reticularis. Reticularis is your sex zone. That's the one where you find your sex hormones, like your androgens, estradiol, testosterone, those kind of things. You think about the zona reticularis. So if you see, it spells GFR, right? And that G is salt, right? Okay, I'm kind of lost. How? Tell me how, Constance. How you lost? What did I do? Tell me, please. What did I say? Yes, they're all in the cortex. Those are the three zones of the cortex. The adrenal cortex broken up into three zones. GFR, zona glomerulosa, zona fasciculata, zona reticularis. They are all in the cortex. Got it? Good. So the next thing is to understand is that each zone, so if you look at the G is salt, the F is sugar, the R is sex, right? So if you look at the zones going from out in, like from the top is the glomerulosa, then in the middle is the fasciculata, then after that is the reticularis. So you have glomerulosa, fasciculata, reticularis. So you're starting from the top and you're going down to the reticularis. So in the medical school, what they teach, the way to remember it, is that salt, sugar, and then sex. Then the deeper you go, the sweeter it gets. So that way you can remember exactly what's in each zone. Everybody understand that? Nobody gets it. All right, let me keep moving. Epinephrine, norepinephrine. So epinephrine and norepinephrine are what you're going to find in your adrenal medulla. Okay? That's the adrenal medulla. The mineral corticoids. Mineral is sodium. Mineral. When you think of mineral, you think of salt. Think of salt, think of sodium. Think of sodium, think of aldosterone. Which zone is that? Which zone? Which zone is that? Right, it's the zona glomerulosa. Very good. The next one you see is blood pressure. Yeah, so that's what mineral corticoids. Glucocorticoids. What zone is that? Very good. Fasciculata. Yep. All right, good. Perfect. Okay. So let's do some questions. And the way we do these questions is I'll ask the question. You see the question. I'll ask somebody to answer it, and then I'll ask everybody if you agree or if you disagree. And then what you'll do is you'll hit agree or disagree. So, John, answer this question, and then everybody else will either hit their agree sign or disagree sign. John says the answer is B. Now, everybody post your agree or disagree. Joan agrees. Ambria agrees. Constance, there's a thing at the top. You just hit agree. You see the little man with his hand raised up? Click that little thing, and then you should. There you go. All right. Don't raise your hand though. I see you raise your hand. Okay. All you gotta do is hit agree. If you click the little down arrow next to the man, you'll see something that says agree, disagree, applaud. Okay, now you got it. John. Okay, in moment, I haven't gotten any response from you yet. I agree. So everybody agree with him? Let's see if he's right. The answer is B. Very good. Outstanding. Good job. Good job. See, now when you do a good job, then there's a applause thing. You can applause it. That's good. All right. This one is for Ambria. Okay, Constance, uncheck yours, Constance. Uncheck it. Okay. All right, Ambria says B. Y'all agree? Everybody agrees. Okay. Now, Ambria, Constance says no. What's the answer, Constance? Constance says C. Zona fasciculata. She said that it's the zone that's involved with. She says, "How can you be?" Well, that's just you can be obese with the thin extremities because that's how the fat is distributed to the midsection in this condition, in this Cushing's disorder. So Constance says that it's the zona fasciculata. Now we know that zona fasciculata is located where? In the adrenal cortex. But they saying that this area is where? In the hypothalamus. So Constance, you know that's not right, right? Yeah. So this actually, and I didn't mean to do this to you, Bria, but this was actually a trick question. The answer is none of these. Because none of those are involved with Cushing. Yes, that was trickery. That was trickery. But, you know, you could have said none of the above. I just did that. All right. Let's see. Let's go with Donish. Donish says C. Ambria disagrees. Constance disagrees. Moment agrees. Dang. Everybody disagreeing except Moment. Moment is the only one that agrees. Now, Moment changed his mind. Wow. Okay. So, Donish, they don't think it's C. So, let's see. All right. Let's see what the answer is. Would anybody like to raise their hand and take a shot? Say what they think? What you think, Ambria? Ambria was first. Ambria? Ambria says thinks it's B. John says it's B. Okay. Moment says it's B as in boy. Okay. Guys, let me ask you one question. Is my voice coming through clearly? Good. When I told you about calcitonin, I told you that calcitonin tones down the blood calcium, right? Yes, good. So if it tones down the blood calcium, then it does not increase the blood calcium, right? That's true. So Dr. Sutton, what the heck did you do? Now, let me just tell you something. Is it D? Is that right? Is it D? No, it's not D. Why you said, oh my God? It is not D. Is it D? Of course not. Because if you increase the bone density, that means that the blood calcium is doing what? Going up or going down? That's right. Good. You're right, Embria. Perfect. So the answer is not what? D. Y'all follow me so far? You with me? Good. Now, the second one is calcitonin a steroid? No. Calcitonin is not a steroid. So we know C is wrong. Okay? But wait a minute. Does calcitonin increase blood calcium? Nope. So B is wrong. Does calcitonin increase? Okay, resorption means that the bones break. And when the bones break, blood calcium goes up. So if you break the bone, you release the calcium into the blood. That's called osteoclast. So osteoclast, so when you spell, like if you see the word osteoclast, the C stands for crack bone. Everybody understand that? So when you crack the bone, what happens to the blood calcium? Increases. Good. Does calcitonin increase blood calcium? Nope. So then is A right or is A wrong? Wrong. Good. So A is not right, B is not right, C is not right, and D is right, but D is really wrong. Pretty good, huh? I like that? Sure. Yep. Oh, well, I missed it. Oh, shoot. All right, I already let the cat out the bag. That's no good. So I was asking about which one will increase pressure. That's okay. We already did that. Wait, you confused, Embria? Embria, there's no right answer to that question. Oh, you said why was it not B? Oh, let me go back. What did you say, Mo? Tell us. Don't tell us you're tricking us and that you're not a doctor. What in the world are you saying, Bowman? I do not understand what you're saying. What is that moment? Am I an engineer? Or something else? I am many things, Moment. But at the present moment, I am your drill sergeant. Got it? You understand? Any questions? All right. So B is wrong because it says increase blood calcium through a second messenger system. Okay? Increase blood calcium through a second messenger system. First of all, calcitonin does not increase blood calcium. Calcitonin decreases blood calcium. So that's why B would be wrong too. You understand that, Embria? Exactly. B is not right. A is not right. C is not right. D is right. But they're asking for the answer that's not right. So the point that I'm making here is that none of these are right. Okay, you get it now? All right. Does everybody get that? Any questions? Nope. Good. All right. So next time, I don't know what's in your schedule, but please make sure before you go to class, you read before class. Everybody understand that? You got it? Yes. Any questions? Okay, I saw that, Embria. No questions? By email. So I'll send the slides by email and keep all the details in the chat. I would just say skim through the chapters, mainly skim through the chapters to kind of have an idea of what we're talking about. But I would definitely read the different chapters. Okay, understand it? All right. Well, I will stop the recording now. So we have covered the endocrine system and everything. And if you don't have any other questions, you all have a great night. Okay. Bye bye.
A moment.
Yeah.
Yo, what was that question you were asking? Oh, I saw the recording, dude.
I was like, he's always tricking us. So I'm like, what happens if he's